And eventually they will give in a big earthquake. There's simply no way that could not happen. I can't imagine you could ever stop a volcano from erupting. But if you discover an asteroid on a collision course with Earth, it can be, at least in principle, it can be deflected. You need lots of warning. And then you stay in the spacecraft out and change its orbit ever so slightly. You either speed it up or slow it down. So when the time many years later arrives that the spacecraft and the Earth would have hit, the spacecraft is either 6 minutes early or 6 minutes late and misses the Earth. And this is a practical thing in principle, although we don't know exactly how to do it. It only makes sense if you have decades of warning. If we found one by a fluke with a month warning, well, drink your best bottles of wine, because there's nothing anybody can do about it. There is one asteroid that's been particularly interesting called Apophis. When it was first discovered, while the orbits were still quite uncertain, by just an amazing fluke, it turned out that the formal errors were such that it had an estimated 2% chance of impact on Friday, April 13th, 2029. And this was by far the biggest red flag that's ever been raised in this survey. And we discovered that on the 24th of December of 2004. The orbit was calculated to show this high probability on the 25th of December 2004. And it probably would have hit the newspapers on the 26th of December 2004, except you may remember something else happened then. The earthquake and tsunami completely dominated the news, and properly so. 250,000 people killed. And by the time that got off the front page, a week later, we had recalculated the orbit, we had new data, and it turned out you never heard about this. But when something gets to be that kind of probability, you can do an interesting thing. You don't know whether it will hit, but you can say if it hits, we know it will be along this line, which is basically the projection of the orbit of the asteroid onto the map of the Earth. So when we thought there was a 2% chance, Rusty Schleichart in particular went through the first one of these calculators and said, the whole Earth isn't at risk. It's just along this line. And then you look at where that line goes. Crosses London, very close to Paris. It crosses northern Iran, Afghanistan, India, and so forth. Now, let us suppose that one had the technology to change the orbit a little bit, and you were going to move its point of impact. Think about the political implications once you're talking about a particular object. Would you be more worried about a hit on London or a hit on Afghanistan? And who makes those kind of decisions? Well, one of the biggest proponents of planetary defense was Edward Teller, the father of the hydrogen bomb, who lived just a few miles from here during the last couple of decades of his life. And he became a strong advocate of using nuclear explosives to deflect asteroids. People have speculated about why he felt this way. Clearly, as the father of the hydrogen bomb, he kept hoping that his bomb could be of some use other than annihilating people. And I think he really thought that this was an opportunity to develop a new generation of bombs, not to attack other people on Earth, but to attack asteroids. And I was with him in 1994 when he made his first visit to the atomic city of Snezhinsk in Russia, in the Urals, the equivalent of Lawrence Livermore Laboratory. And we saw the world's largest bomb. It's a mock-up of it in their museum. It's supposed to have been good for 100 megatons. It was actually fired at, I think, 60 megatons. And Teller blithely said, we can make one 100 times bigger than that. Let's go out and do it in case we have to protect against an asteroid. Not everyone agrees with that. And one of the big questions has been what actually should be the approach you would take to defense. There are a number of technical suggestions. One of them is indeed to use a nuclear bomb. although it's not one that's very well understood, because while we know what happens with a nuclear explosion on Earth, a nuclear explosion in space is very different. There's no fireball and shock wave to move the asteroid the same way it would be on the ground. And Teller recognized that, and his position was that science has to do with experiments, and so what we should really push for is an experiment to nuke a poor innocent asteroid and see what happens. Not necessarily a bad idea. Most of us think, well, we can wait. We don't have to develop an asteroid defense because the Space Guard type survey will give us decades of warning. And so why spend the money now when we don't know what we're going to have to defend against? We don't know when we'll have to defend. But the question is, well, should we be doing some preliminary work now? Everybody seems to agree we should carry out the survey. But the idea of beginning to take the next step so that we could do something if we found one headed for the Earth is more problematic. And it's a matter of money. How much should we spend on the defense of the planet? It's a matter of responsibility. Is this an international effort? Is it something for the U.S. to do? We're the world's only superpower. We seem to think we can police the rest of the world in various other ways. Maybe we should also develop an asteroid defense. But then, can you trust the U.S. or anybody else to do that? Since this lecture is part of my Sagan Medal thing, I want to conclude by talking about Carl Sagan's position on this, because he, like Teller, became very interested in the last years in his life in the question of protecting against asteroids. It's a very real danger. It just doesn't happen very often. And he was concerned about the risk, but he was also concerned about the hazard inherent in developing a defense system. He even pointed out, for instance, that if you had the technology to take a dangerous asteroid and deflect it away from the Earth, you had the technology to take an asteroid that would have missed us and deflect it into the Earth. And what was the risk of that? He called this the deflection dilemma. If you develop the technology to do a good thing, you may end up having an unintended consequence that's even worse than what you were doing. And he typically had a good imaginative way to illustrate this by telling a story, a true story, called The Marsh of Camarina, about the Greek city-state in about 500 B.C. In Sicily, which was Magna Graecia then. And I'm told, a completely true story as far as we can trust the history back that far. They had a health problem. And I don't know if it was malaria or what, but the city fathers figured out that the swamps around the city were probably the cause of the problem. So as a public health measure, to make their citizens more healthy, they drained the swamps. The enemies around them, as soon as the swamps were gone, realized the city was undefended, attacked, burned it to the ground, killed all the men, and put the women and children into slavery. And there's been nothing left ever since. So this is Sagan's parable about unintended consequences, that doing a good thing, trying to improve people's health, could ultimately have a much worse consequence. Sagan, however, in the end, I think, had the right perspective, because he said, if we look at this from a long-term perspective, if we think about not just this decade or this century or this millennium, but if we talk about human civilization surviving for hundreds of thousands or millions of years in the future, then asteroid impacts are the biggest risk. They are the biggest known natural hazard. Very rare. But they could end civilization. They could even produce the extinction of humanity. It happened to the dinosaurs. It could happen to us.